Now, optimization. Optimization allows us to apply the first derivative test, and using the first derivative to find maxes and mins, but it allows us to find the maximum or minimum amount of a certain number with a given parameter. For example, say we have a fence, a river, right? This is our river, and we have a fence. And this fence, we only have an amount of material, right? Our amount of material, we only have, say, 100 feet of material. Now, if these two sides are x and this side is y, we want the maximum area we can get for this material, for this fence, using 100 feet of material. So we're trying to find the max. Now, the equation we're trying to find the maximum area. So the equation that we're trying to maximize is the area equation. So x times y. And we want that's going to be the area. We want to maximize that. But when we're optimizing this, we have 3 variables. We need it to just be 2. So we need to find an equation that relates x and y and allows us to solve for a certain, let's say, y, for how y corresponds with x. To put it into place, we have the perimeter of 100 is going to be equal to 2x plus y. That means y is equal to 100 minus 2x. So x times 100 minus 2x equals a. You distribute 100x minus 2x squared equals a. This is our equation for the area of fence with a given x value. Now we can maximize it by finding the first derivative. 100 minus 4x equals a prime. And now we plug in 0 to find the relative extrema. And so 100 minus 4x equals 0. 4x equals 100. X equals 25. That is our maximum. That's our x value to maximize the area. Now, just being sure, we can find the second derivative, which is just 4x, negative 4x. If we plug in 25, a double prime equals negative 4x. We plug in 25, we will get negative 100. And because that is negative, that means this is a relative maximum. So this is the x value for the maximum amount of wood or fence we should use on each side to get the maximum area. Now, to find the y value, we simply plug it back into this. So 100 minus 2x is 25 equals y. 100 minus 2 times 25 is 100 minus 50 equals y, which equals 50. Now, so now we know our perimeter, and if we're trying to find the maximum area, then we can just plug our x and y's into here. So 50 times 25, and that is going to be equal to about 1,250 feet squared. Write that down here. 1,250 feet squared. So we found the equation for the area, and we brought in a similar equation to make it to where we only had one variable, and then we maximized this equation, plugged back in to find the maximum area and the x and y values that correspond with it.